టైం 9 అయిపోయిందా?
మౌస్ ఒకటి ఆఫ్ చేసి
Am I audible? Mohan Babu sir, am I audible?
వినపడుతుంది సార్.
వినిపిస్తుందండి?
బానే ఉంది.
ఓకే ఓకే ఓకే.
వినపడుతుంది, బానే ఉంది.
సో మీరు వాళ్ళని అడ్మిట్ చేయటం మీకు కుదురుతుందా వచ్చినటువంటి వాళ్ళని?
నాకు అడ్మిట్ ఏం ఆప్షన్ రావట్లేదు సార్.
ఓకే ఓకే, అయితే నేను
స్క్రీన్ షేర్ పెట్టారు, కనపడుతుంది.
Let us start our today's session. Uh, so let us start our today's session. Uh, Big data analytics. So really some more people are in waiting room. Okay. So now, as you all aware of that, big data is one of the emerging area in the current scenario. So now let us look at about the syllabus of the big data analytics. So for the time being, I'm muting all. Uh, whoever is having any doubts, you can raise your hand and you can unmute yourself and you can ask the doubt during the session. Okay. So now the first unit is dealt with data structures in Java, linked list, stacks, queues, sets, and maps. Because the entire big data technologies like Hadoop are implemented based on Java. So you need to familiarize with some of the fundamental data structures which are used in our MapReduce program. So for that reason, for giving awareness, the first unit will be the first unit consists of linked list, queues, and all, and uh, generic classes, generic methods, and wrapper classes. As you might have some idea regarding Java and data structures which you studied in the previous semesters, a wrapper class is a class whose object wraps or contains primitive data types. That means by using these generic or the wrapper classes, you can convert the primitive data type into objects. With the help of wrapper classes, you can convert primitive data types into objects. So in the package java.util handles only objects. So hence wrapper classes help in this case. Okay. And similarly, the generic classes. So in the generic classes, usually for the methods, will when we are while writing methods in the class, will pass some arguments. So instead of passing the values, you can pass type parameters. Okay. So what is the use of developing generic classes is stronger type checks at compile time, and it eliminates the cast, typecast. As you all aware of the converting one data type into another data type. So it eliminates casts also, right? So that is about the first unit. When coming to the second unit is working with big data, Google file systems, Hadoop distributed file system, and building blocks of Hadoop. Okay, Hadoop is an Apache open source framework written in Java that allows distributed processing of large data sets across clusters of computers using simple programming models. So the Hadoop framework application works in an environment that provides distributed storage and computation across clusters of computers. Hadoop is designed to scale up from single server to thousands of machines. So it is a open source distributed processing framework. That means Hadoop is able to handle huge volumes of data which is stored in clusters of commodity hardware. Okay, the name it implies big data analytics. Big data. What do you mean by big data? How will we measure it? Okay, so as far as concerned, if you are talking about, let us consider a simple example. Let us consider a 1 liter water bottle. What will be the capacity of that bottle? 1 liter. So if you want to pour more than 1 liter, what happens? It is a big for that water bottle. That means whatever the capacity that it will have, if you try to keep more than that, it becomes big for it, as far as concerned with that particular water bottle. In the similar way, when we want to keep, because as you all aware of that, in today's scenario, and the Facebook, social media, Facebook, Twitters, and all will post a number of videos, audios, okay, text, and all. This all becomes huge. So here the question is how to accommodate all this data and how to process it and how to analyze it is a difficult data. So as a part of solving all these kind of problems, we'll come across with the Hadoop technology, right? So Hadoop is a open source framework for the distributed processing of large data sets across the clusters of computers. Now, HDFS, Hadoop Distributed File System. Hadoop, it is one of the core component of the Hadoop. Hadoop Distributed File System is based on Google File System and provides a distributed file system that is designed to run on commodity hardware. So as I told you, with the help of this Hadoop, we can store huge volume of data and we can process it. So during the processing, how the data is going to be stored in various systems, those all things will be taken care by Hadoop distributed file system. Just like you can imagine, you can think about the file system in your computer. What way your file system will work. In the similar way, HDFS works to keep the data of huge volume of data, right? Now, building blocks of Hadoop, because these are the key components: name node, data node, secondary name node, job tracker, and task tracker. So these are all the 5 essential components of Hadoop. Name node is the key node where all the information, all the inputs are supplied to the name node. So name node itself, it will be distributed to the data node. It will be distributed to the data node. Just like you can imagine a client server environment where all the information will be posted to the server, and then it will be how it will be distributed to the clients. How the clients are going to be access it and what way the communication will be taken place. In the similar way, all the communication will be through name node only. So through, suppose if you give a large data set as an input for processing of something, okay, that input will be supplied to the name node. In turn, it will be divided into parts, and those parts will be supplied to the interconnected nodes. Okay, so in the Hadoop environment, we'll have one name node and followed by number of data nodes. Okay, so the name node will distribute the blocks of data to the data node. Data node consists of job tracker and the task trackers. So they will take care of processing of the data which is it is received from the name node, right? And again, after completion of the task, they will be submitted to the name node. So these all things will be managed at a data node. And whenever, as it is quite natural, there might be a possibility of failure of the name node. So if the name node is the key entry point for all these things, so if it gets failed, and then what happens? The entire system is going to be collapsed. So that is the reason, as a standby, we'll use the secondary name node. So what secondary name node does is simply it acts as a backup for the name node. It won't do anything. Just it maintains a copy of the information which is present in the name node in the secondary name node. That's why it is called as secondary name node. Whenever if the name node gets failed, okay, automatically secondary node will take care of all the responsibilities of the name node, and it ensures the smooth running of the functionings until the name node has restored. So in such a way, the secondary name node will work, right? So that is about a simple information about Hadoop. Now coming to the third unit, that is MapReduce. So Hadoop majorly consists of two important components. One is MapReduce programming, and another one is HDFS. So MapReduce is a programming model where we'll divide the parallel programming model for writing distributed applications devised at Google for efficient processing of large amounts of data and large clusters, thousands of nodes of commodity hardware in a reliable, fault-tolerant manner. A MapReduce program runs on Hadoop, which is an Apache open source framework. So the total, whenever if you want to solve a particular problem, okay, so you need to be divide. Suppose, say for example, if you want to count the number of words in a given paragraph, the number of words which are present in a paragraph, what you should do is you need to write two different methods. One is mapper logic and another one is reduce logic. So what mapper logic does is initially the total paragraph will be split. Suppose, say for example, in the unit 2, if you observe 4 lines are present in that paragraph. Okay, so here each line will be supplied as an input to the one mapper function. And what it does, the mapper function finds the number of words. Say for example, in the first line, if you observe working with big data, Google file system, Hadoop distributed file system. If you observe, the file and system are the two different words which are repeated in 2 times, and all other words in that line present are single line. So what the mapper 1 logic produces the output is working 1, with 1, big 1, data 1. Okay, like that, how many number of times the word is repeated in that line, how many number of times the word is repeated in that line will be produced as an output. So in similar way, second line will be supplied as an input to the second mapper logic, and third will be supplied as input to the third mapper logic. Like that, whatever it may be, the number of mappers are essential for that. Okay, so you can supply in such a way, and whatever the outputs that are produced by the mapper 1 and mapper 2 and mapper 3 and all the mappers will be consolidated by the reducer logic, and finally it produces the number of, just a minute. So in the reducer logic itself, uh, it consolidates. It consolidates. That means, suppose if you have developed 4 mapper logics and 2 reducer logics. Okay. So what mapper logic does? It reads the input line and it produces whatever it may be the number of words which are present in the line, and as well as how many number of times they were repeated. So that is the output of the first mapper logic. Similarly, second mapper logic will also, mapper logic in the sense it is a function defined by you. In such a way, you are supposed to write the code by using available methods and classes in the Hadoop system, or simply you can call it as Java, right? Why I'm calling it as Java in the sense you are supposed to write the code using Java. So that's why I'm saying like that. And third mapper logic will produce the output, and fourth one. So if the first 2 mapper logics outputs will be supplied as an input to the reducer 1, because we have 2 reducers. So the first 2 mapper logics outputs will be supplied as an input to the reducer 1, and the second, that means mapper 3 and mapper 4 logics will be supplied as an input to the reducer 2. Okay. So what reducer does is, it takes what is the input of the input supplied to the reducer, number of words followed by the count. So what it does is it merges the outputs of mapper 1 and as well as mapper 2, and finally it verifies. Suppose sometimes, say for example, suppose let us imagine in the second line also, unit 3, in the second line also there might be a word called file. In that case, what happens? In the first line you will observe two words, or sorry, a word which is repeated 2 times, file. Okay. And in the second line, suppose one more word is present, that is file is present. What it does is it makes the count of that word as 3, because 2 times it was repeated in the line 1 and 2 times it was repeated in the line 1, and imagine if the third line is also consists of it. So what will be the total count of that file? Now it becomes 3. Okay. In such a way, all the words which are present in the output of mapper 1 and as well as mapper 2 will be consolidated, and finally it produce the output. In the similar way, reducer 2 will also do the same. Suppose if you are using here, the question is how many number of maps are going to be defined and how many number of reducers are supposed to be defined, and how we will consolidate the end result. These are all things which we will discuss while discussing the unit 2. And then you just remember that the Hadoop program MapReduce programming will implement 2 different methods. One is the mapper logic and another one is reducer logic. The job of that mapper logic is whatever the input it was, raw input it was supplied to it will be consolidated. Okay. And the reducer logic is simply it merges the outputs produced by the mapper logic. Right. Now coming to the unit 4. Unit 4 will deal with some of the important classes and as well as methods that are used for developing MapReduce programming. MapReduce programming, right? And now coming to the 5th one, that is PIG. One of the PIG is a high-level programming language useful for analyzing large data sets. It is a high-level programming language useful for analyzing large data sets. A PIG was a result of development effort at Yahoo. That means it was developed by Yahoo. So in a MapReduce framework, program needs to be translated into a series of map and reducer stages. As I told you, while counting the number of words which are present in the given text, what mapper does and what reducer does, as I told you. So a series of steps need to be, stages need to be followed. However, this is not a programming model which data analysts are not familiar with. So Apache PIG enables people to focus more on analyzing bulk data sets and to spend less time writing MapReduce programs. So, pig architecture, if you observe, pig architecture consists of two components. One is pig Latin and another one is a running environment for running pig Latin program. So what pig Latin? A pig Latin program consists of a series of operations or transformations which are applied to the input data to produce output. So these operations describe a data flow which is translated into an executable representation by pig execution environment, right? So now the pig has two different execution modes. One is local mode and another one is MapReduce mode. In the local mode, it uses single JVM, Java virtual machine, and make use of local file system. So this kind of mode is suitable only for analysis of small data sets using pig. But in the real-time scenario, we are supposed to be dealt with huge volumes of data sets. So in that case, we'll go for the MapReduce mode. So in this mode, queries written in pig Latin are translated into MapReduce jobs and are run on Hadoop clusters. Right? Cluster means n number of systems are grouped together and make it as a single unit. Right? So a MapReduce mode with a fully distributed cluster is useful of running pig on large data sets. Right? Now, what we understood is there are different ways to organize a MapReduce operations. The first one is you just write directly you can write the MapReduce programs for structured, semi-structured, and unstructured data. So now you are supposed to understand what is structured data, what is unstructured data, and what is semi-structured data. Structured data in the sense it was organized in an well-defined structure. If you think about data DBMS, okay. So where in the database tables, all of them are defined in a predefined format. So all the data which is present in the table should follow the same format, right? So, but in the real-time scenario, there are some videos, some audio. They are not following the similar format. So that kind of data, which we can call it as unstructured data. And a middle of these two, that means they were organized in an certain standard format, but they behave in a different way. So such kind of data is semi-structured data. Of course, we will discuss in detail while discussing the applications of big data and all. So until then, just remember that broadly will be categorized that the whole data into three categories: structured data, semi-structured data, and unstructured data. Right? So you can write the MapReduce operations by writing the Java MapReduce program, or you can write the scripting approaches for the MapReduce to process structured and semi-structured data using pig. And another important aspect is you can write the MapReduce operations by using Hive. That is your 6th unit, Hadoop data with Hive. Okay, the Hive is a query language. You can call it as a HiveQL or HQL for MapReduce to process structured data using Hive. So now you might have a doubt like, for what is Hive? Hive is a data warehouse infrastructure tool to process structured data in Hadoop. Hive is a data warehouse infrastructure tool to process structured data in Hadoop. It resides on top of Hadoop to summarize big data and makes querying and analyzing easy. Right? So you can think about it is just like an SQL. You might have feel while writing programs in Hive, so you might have feel like it is similar to the SQL. Not same. You may feel like that SQL type language for querying, so called HiveQL or HQL. It stores schema in a database and processes data into HDFS. Stores data in databases and processes it in HDFS. And it is designed for OLAP. as you are familiar with OLAP and all these things in data warehouse, right? Uh, that is a small introduction about the your syllabus. You can see it consists of 6 units. Each and every one is having its own significance. Now, these are the textbooks and reference books for the entire syllabus, right? Now, coming to the objectives, course objectives. The course objectives mean, for the first one is introducing Java concepts required for developing MapReduce programs. As I told you in the first unit, we are discussing about linked list, stacks, sets, and other generic classes and wrapper classes. These are all used for developing MapReduce programs. Okay. Now, coming to the second one, optimize business decisions and create competitive advantage with big data analytics. So as I told you, how to handle the big data and how we are going to be process it, and all these things we are going to be discussed. And coming to the third one, derive business benefit from unstructured data. Business benefit from unstructured data. As I told you, you can think about a video is an unstructured data. Suppose, as you all might have experience with posting videos in social medias and other like Facebook, right? See, there you might have observed one important point is, suppose if you search for a particular kind of videos, okay, probably you may get it and you can watch it and finish. The next day, if you open your social media account, when you try to do something with that, you might have observed whatever you searched yesterday, the similar kind of things are appeared in it. For example, in the Flipkart or in the Amazon, if you search for a particular product in the today, right? You have searched, you have identified, you have analyzed it. Okay, blah blah blah. You did something with that. Okay. Tomorrow, if you open the same Flipkart or Amazon, you might have observed that some suggestions which are related to the search which you have done yesterday. What it means? What it means? So the e-commerce organization is analyze your data, and based on your interests, it suggests you some of the other. So how it does? You are only the customer of e-commerce? No, there are billions of customers out there. How it find out the, you can imagine, you can think about what way they are going to be analyze all these things, how difficult it is, right? So in such a way, they all analyze your interests. Based on your interests, they will give some suggestions. And another important, beautiful example is in the Facebook, if you observe, you'll get some the people you may know, friend requests, the people you may know. How it finds, because majority of the users it shows to you are known to you. That means, suppose today, if you open your Facebook and you can observe 10 people suggestions. Out of 10, at least 5 or 6 are known to you. So how it is possible? How it is possible? How it finds the people which are relevant to you? So these all kind of things will be done. So there are several algorithms, several procedures that will we are going to discuss to implement such kind of things. Not exactly the same. We'll implement such kind of things. So derive business benefits from the structured data. And coming to the fourth, importing the architectural concept of Hadoop and introducing MapReduce programs. As I told you in the unit 3 and 4, we'll discuss the Hadoop concepts and how we are going to write the MapReduce programs and all. We are going to be discussed. And last one is to introduce programming tools, Pig and Hive in Hadoop ecosystem. Now, what exactly Pig and what exactly Hive we have discussed, and how these tools will be used in the Hadoop ecosystem to handle the large volumes of data. So these are the core objectives of big data analytics. Now, coming to the last one is course outcomes. The last one is course outcomes. All right. So after learning this course, you are able to preparing for data summarization, query, and analysis. So how do you summarize the data before going to perform the analysis, and how do you extract the data from the storage area, that is called as query. So these all things you are able to expedite. And second one is course outcome 2 is applying data modeling techniques to large data sets. Data modeling techniques. As you all familiar with DBMS, and you know what exactly the data modeling and all. Okay, so how to handle the large data sets, and what way you can model it, and what way you can analyze it. These all things will be learned at the end of this course. And you are able to create applications for big data analytics. You are able to develop the solutions using MapReduce programming, and as well as Big, and as well as Hive. So in the course outcome 4, we'll discuss about all these things, like acquire fundamental enabling techniques and scalable algorithms like Hadoop, MapReduce, Big, and Hive in big data analytics. So these all things you are going to be familiarized with all these things. Last, building a complete business data analytics solution. So at the last, you are able to develop your own application to solve a business need. Right? So these are the course outcomes of the